All right, so as I was saying in the last video, part one. This is part two. The surface of Venus, using the Magellan spacecraft with radar that can pierce through the clouds, we've been able to determine that a lot of Venus is flat. There are some mountainous areas, or more or less hills. I mean, you can call them mountains. There's an example. This is all, of course, in false color, and like I said, there's evidence of within the last million or so years that Venus has resurfaced itself. So there's a lot of geological activity going on, and certainly a lot more study needs to be done about concerning Venus. Mars, of course, is one of our favorite targets to land spacecraft on. Mars has it's of course much smaller than the Earth. It has an atmosphere, mostly carbon dioxide, just like Venus is, but unlike Venus, the density of Venus's atmosphere is about 100 times that of the Earth, whereas Mars, it's just the opposite. It's about 100 times less dense than that on Earth. So the pressure is much less, and there's a reason for that. Actually, it turns out that because Mars has almost no magnetic field, the solar wind, the particles that come from the sun naturally in all directions, with the Earth, of course, our magnetic field bends the oncoming charged particles around the Earth and to the poles, whereas with Mars, that has not been the case, certainly for many billions of years. And so Mars's atmosphere has been deteriorating ever since Mars lost its magnetic field. Let's see. So it's about 1.5 times the Earth-Sun distance from the sun. So 1.5 AUs. There are wonderful examples of volcanoes all over Mars. In particular, there's one particular volcano which is, oh my goodness, it's more than 10 times the size of Mount Everest, called Olympus Mons. In fact, it is the largest volcano or mountain, because it's not active now, so it's a mountain in the entire solar system. So it's gigantic, and we have strong evidence from space probes and space rovers that have landed on Mars and taken pictures, and also looked at the samples, the Martian surface, and actually done chemical analysis on it, that there was very long time ago liquid water on the surface of Mars. Mars is too cold now, though, for liquid water to be right on its surface. So perhaps back billions upon billions of years ago, Mars had there's the evidence is there that there was liquid water on Mars. Jupiter, so between Jupiter and Mars, of course, there is the asteroid belt. I'll have more to say about that later. Jupiter, of course, is the largest of the planets. One of the features, of course, is the Great Red Spot. Even Galileo saw it, over 400 years ago. It's about 5 astronomical units from the sun. It is, if you were to take the Earth and multiply its mass times 318, you would get to the mass of of Jupiter. It's made mostly of hydrogen and helium, just like the sun. It's about the same percentages of the sun, around 70 something, 71, 72% hydrogen, and 20 something, 25 something like that percent helium. And we think that it has an iron silicate core. Of course, there's the Great Red Spot. There are these bands. Here's the thing that's different about the terrestrial worlds, Mercury, Venus, Earth, and Mars, versus the gaseous worlds. And I use that term, or the Jovian planets, but the gaseous world is a really good way to describe these planets, starting with Jupiter, because there is no surface. Let me make sure that everybody understands that. There's no surface to land on. All Jupiter is clouds that get thicker and thicker and thicker until perhaps you actually get to the core. There might be, there's some estimates that you would find metallic hydrogen at the core, but we really don't know at this point. I mean, that's just based on the size of Jupiter and what its density and what its temperature possibly would be at the center. Anyhow, when you think about like landing on Jupiter, you can't. You simply can't. Now Jupiter has the most moons of any of the planets in the solar system. There's well over 60 moons. The four largest ones were discovered by Galileo, back over 400 years ago. There's Io, Europa, Ganymede, and Callisto. Back in the 1970s, we launched Voyager 1 and 2 spacecraft that went by, did flybys of Jupiter and Saturn. Voyager 2 in the 1980s went on to go by the planets Uranus and Neptune, which really gave us all the almost all the information that we have, or not almost all, but a lot of the information that we have on Uranus and Neptune, because we haven't sent spacecraft back to those worlds. Jupiter and Saturn, of course, we've had spacecraft that have orbited for many, many years. In fact, the Galileo spacecraft has given us the most information about Jupiter and its moons. For Saturn, of course, it's called the Cassini spacecraft. All right, what else to say? Jupiter's world, Europa, is of great interest to us, and for the same reason that Saturn's moon, called Enceladus, is of great interest to us, because with those particular moons, Europa for Jupiter's, which was Jupiter's moon, they both seem to have ice that is water ice that is the surface, and there's strong evidence that underneath the surface there's liquid water, and in fact we think more liquid water than is in all the oceans of the Earth. So that there's that. One of the things that we've done, in addition to just studying the physical aspects of these worlds within our solar system, is to realize, of course, that the Earth is the only planet that has life that we know of, and all life on Earth requires liquid water. And so, even though these worlds, these moons, are further from the sun and don't receive, they're clearly any water would be frozen. There might be sources, like for example, with these moons, there could be a squeezing that takes place from their host planet, a tidal squeezing, and the interior of these planets might be hot enough for there to be liquid water. One really strong, very strong evidence of this is the large Galilean moon called, well, it's not really large, it's one of the smaller ones, called Io, which is the closest of the four Galilean moons, the four moons that Galileo discovered. Remember Io, Europa, Ganymede, and Callisto. Anyhow, Io is the most volcanically active moon in the entire, or world, including planets, that we've ever observed in the solar system. And that was actually discovered by Voyager 1. There was a flyby in the early 80s of Voyager 1 spacecraft, and there was, these plumes that were unexplained when they first looked at them, and then later on people figured out that they were volcanoes going off on and why would this little tiny moon have volcanoes going off? What we believe is because it's being squeezed. The entire moon is being squeezed by Jupiter as it goes around in its elliptical orbit. So when it's closest to Jupiter, it gets squeezed even more. When it's further, then it releases some of that tension. And anyhow, I could go on and on. One last thing. I think I mentioned this, that of course the Great Red Spot is a giant storm that even Galileo saw. There are other storms that are on Jupiter, but they certainly don't last as long. All these bands that we see on Jupiter are atmospheric effects, and so there's these different bands. The Great Red Spot has been around at least 400 years, and we think perhaps thousands of years. Although recently, it has been observed to be shrinking, very slightly, but shrinking. We don't know if that will continue. Let's see what else. Blah, blah, blah. I think I did all this. Its atmosphere does have ammonia and methane and, of course, water. There's a close-up of one of the other spots. There's the Great Red Spot above it. Of course, there are the moons. Now turning to Saturn. Of course, Saturn's greatest feature is its rings. The rings are little tiny dust particles that somehow we don't exactly know how. Perhaps two moons crashed into each other. We don't know exactly how that happened. Let's start with the distance. Saturn's almost 10 astronomical units away from the Sun. The rings are the main feature. The density, it's just like Jupiter. Saturn's density is close to that of liquid water, 1 gram per cubic centimeter. But Saturn in particular has a density of 0.7, so it's actually less dense than liquid water. So if you had a bowl large enough, which is impossible, you could actually float Saturn on in that bowl of water. Saturn's largest moon, Titan, actually has an atmosphere, a pretty substantial atmosphere. I mentioned that Saturn had a space probe that orbited it for many years, called Cassini, and Cassini had another probe that was actually launched and landed on the moon, Titan, and took pictures and we got all sorts of information, and is still there on the surface of Titan. The thing about Titan. Here, let me go back. The thing about Titan that's interesting is its atmosphere is kind of the way we think Earth's early atmosphere was. Carbon dioxide, methane, and ammonia, and of course water. All right, I'll continue this probably next week.